because all of you have not done this, and this is not related with your electrostatics also. Then what we'll do, in this week, we'll cover Biot-Savart's law. I'll take your extra class and I'll try to finish off this chapter. Biot-Savart's law will be over. All right. Now, once this Biot-Savart's law is over, what you will do, you will come in the second batch, in your batch. Mariam, you will be coming in your regular batch also. So that 9 p.m. batch, which is 6:30 p.m. KSA timing, that you will all will be coming. So obviously you all need extra classes. You have joined very late. We have started the batch very late. So you need extra classes. And if you are not willing for the extra classes, then your syllabus will lag. I have no issues with completing electric potential and capacitance in the month of July, and then complete current electricity in August, and then start with this chapter, with all these chapters. So it's the best that if you join the other batch too, there we are doing moving charges and magnetism. In that chapter, the only problem that is right now arising is that I have started that chapter and I have completed the entire Biot-Savart's law. I have completed that. Okay, so this is the problem that is arising. So that's why I cannot add you today. For adding you in that batch, I need you all to already know these basics. Otherwise, without the basics, again, you all know how it is difficult to understand the concepts without knowing the knowledge of the basics. Fine. So what we are going to do, once you are parallel with the other batch, you have joined the other batch. In this batch, 4 p.m. batch, we'll be continuing the back. Potential, we'll cover current electricity. Once this is done, then whatever extra classes are switched and everything, you will be informed. We'll do it together so that at least these 4 chapters are completed, and whatever are the syllabus in your schools, different, that we are able to complete it. So is it clear, or any confusion regarding the classes or anything? Right now, you just have to join this batch. When you have to do the doubling, when you have to attend the extra class, I will inform you. Right now, focus on the chapter 4th. Forget everything, because it is magnetism. It's a new chapter. You can relate even if you have no concept of the previous portion. But pay attention here, because since this is a new concept, but it has very tricky portions like the direction part. You cannot write the direction, just write right words to left words and all. Properly, we'll be using right hand thumb rule to figure out what is our answer. So that's why this chapter is very important. It is related to your electrostatics in the way that it comes after electrostatics. But never mind, whatever portion is coming, I'll discuss that first. But focus on this chapter now. 3 classes, I think, will be sufficient to complete Biot-Savart. So let me start with this today, so that let's have a class tomorrow or on Friday, so we are able to complete this portion. Is it clear? Any queries regarding the class joining and the syllabus and exam or anything? All good? Give a thumbs up if everything is clear. Okay, Sufyan, what about Mariam and Taha? Any query?
No, ma'am.
No? Taha is also clear. Good. Let's start with moving charges and magnetism. These extra classes and everything are just for your benefit only. Whatever exams are coming, because you should score good in your half yearlies. Otherwise, we'll be here in this batch. We are very, very far away anyways. So chapter 4 is moving charges and magnetism. Basically, chapter 3, current electricity, which we have not studied, which we will study in the next week or after that. We will see when the charges were at rest, we called that state as electrostatics. Once the chapter 3 has started, we call it as electrodynamics, right? Charges have started moving. Now, what are the moving charges doing and how they are moving? That is all dealt in current electricity. About the circuits, about and everything that is dealt in current electricity. Now, when we are talking about current electricity, one thing you should know about that too is that it's not a part of electrostatics. Fine. So when I'll be using the term here electrostatics, so that won't mean that that I'm referring to electrostatics. So you should understand it means electric portion. This is the magnetic portion. So basically, once these electric charges move, that is in the current electricity, whatever we study, these charges have the tendency to create magnetic field around. Charges were at rest, electric field was there, forces were there, potential was there, like this. Charges have started moving. So current electricity has started, means now the circuits have, the wires have the current flowing in them, like this, fine. Then these flowing charges, these moving charges, they are creating they are creating magnetic. So magnetic field, the way electric field is what? A charge is present. Around that charge, a space is present, which has electric properties in it. Similarly, magnetic field is also a space around a magnet where its magnetic properties also exist. Now, how can you identify whether a magnetic property is present or not? You bring another magnet. This is a magnet. Fine. This has certain field lines. This space in it, like this. It has certain space lines which is going outside and meeting in this. Like this also here it has these field lines. So basically this entire region is the magnetic field, right? This entire region is the magnetic field. Now I have brought another magnet. And as soon as I enter this field, two things can occur. Either it can be attracted or it can be repelled, right? So if it is getting attracted or getting repelled, it means there are certain field or there is a certain space which is existing around a magnet, which is either attracting it or repelling it. That space which is providing this magnetic property portion, that space is basically called as the magnetic field. So एक magnet होगा, हर मैग्नेट पे एक एसोसिएटेड उसकी एक मैग्नेटिक फील्ड, वो एक रीजन में ही प्रेजेंट होगी, एक रीजन तक ही वो कन्फाइंड, ओके, it will be confined to one region. All right. And once this is present, this is confined to one region only. What will happen? In that region, you'll be able to experience all the forces of attraction of or repulsion due to the magnet. This is what is meant by magnetic field. And how do you represent it? You represent this magnetic field by the symbol B with an arrow on the top. What does this arrow represent? Can anyone tell? Why have I put an arrow?
Vector quantity.
Vector. It's a vector quantity. This is a vector quantity, and if it is a vector quantity, it will obey the vector laws. Vector laws mean your parallelogram law. All these vector laws mean the parallelogram law, triangle law, polygon law, whichever. So B, not by M, because there are things, there are quantities which are represented by the letter M. So not by the letter M, by the letter B, represented by B. All right, SI unit is simple. This is Tesla, represented by capital D, and CGS unit is Gauss, represented by capital G. Now, one thing, class, when we were discussing electrostatics, electric charges, when we were discussing, that time I told you that ESU or stat unit, electrostat unit, these units are not often used. Even you have not witnessed them in the questions, right? When we are talking about electric charge, we see coulomb 1, 5 coulomb, 3 coulomb. If there's a modification which is present, so it is written as 3 nanocoulomb, 4 microcoulomb, 3 millicoulomb. So coulomb is there. So we never actually use the conversion of the SI into CGS unit during electric charge. But right now, when you are studying magnetism, in magnetism, 1 Tesla is equal to 10 to the power 4 Gauss. This is often used. This conversion, this is often used. All right. So Tesla and Gauss, once you are converting, so 1 Tesla is equal to 10 to the power 4 Gauss. This conversion is very important because you will get questions where Gauss is mentioned and you have to write your answer in SI unit. So it's better. It's straight away better if you just write your, if you learn this, 1 Tesla is equal to 10 to the power 4 Gauss. Now, one more thing, class. If we are talking about this term magnetic field continuously. So just a basics. This is also a portion of the basics. Nobody is going to ask you all these things. These are just introduction portion, introductory part, which we have to do, right? Because after that, you'll not be able to study if we do not study this. What are exactly are the sources of this magnetic field which is present? So first source is the intrinsic electronic spin. In class 11th, when you are doing that structure of atom chapter, there have you done that question? If 4p square is present or 4p2 is present or 4p3 is present, you segregate all the terms. You write n as 4, n as p, l as this, like this. Yes. When we come to m, you write it as minus half and plus. Why do we write this? There, when we were talking about the atoms, electron spinning. Basically, electrons spin within the atom, the electrons have the tendency to spin. So one side of spinning is termed as plus half, other side is termed as minus half. Like you can take an example, one side means clockwise, other side means anti-clockwise, like this. So the electrons are spinning, that direction determining. This is either plus half or minus. Okay. So that spin, M is, or this S, both are same. Spin basically means minus half or plus half. Okay. So when the electron spins, magnetic field is generated there. That is one source of magnetic field. Second, current carrying wire, which we have not studied exactly. We've just studied charges are static. We'll study this in current electricity, that a wire is present and electrons are flowing inside it. And due to the flow of electrons inside it, there is a production of magnetic field at a particular point. Okay. That current carrying wire is also generating magnetic. Third case, see the magnet le lo, bar magnet, horseshoe magnet, such different types of lighter, heavy, so many magnets are present. So both works are done. Bar magnet is a straight cuboid. Horseshoe is in a form of U. Right, so it is lighter and this is a little heavy, but both have the magnet. Lastly is the case of the solenoid and toroid. So what is a solenoid? Solenoid is basically copper wires or aluminium wires or wires when they are turned in the form of these wounds are made. This is called a solenoid. That is also a source of magnetic field. And if this straight solenoid, you just join the ends like in the form of a circle, join the ends like this. That is called a toroid. Now, electronic spin, intrinsic electronic spin, and what you have studied this in chemistry and you'll not study it here. Is a portion of quantum physics which is not a part of your syllabus now. In higher classes, you will study that. Current carrying wire, this is very important because you have the complete Biot-Savart law based on this. So this is very important. We'll be doing it. About the theory part of magnet, we'll be doing in chapter 5th. So no need of this also here. This we'll do solenoid and toroid. These are in your syllabus. So that time this will be clear what is this. So write down the introduction first. Then I'll start with Biot-Savart's law. Done. Now see, we have this main law, which is Biot-Savart's law, which I have to study. So basically, there's a wire segment, fine. In this wire, current is moving. Now I will choose a small portion of this wire. Let's say the entire length was something. Entire length was capital L. Now I have just taken a small length. This you can remember. Just a small length L that I have taken, which is DL. All right. So if DL is taken, this small length now, this is called as the current element. I is the current of the wire. Now, if I ask you, tell me the magnetic field here due to this wire. So magnetic field is separated by this distance, which is the position vector R. All right. And there's this angle which is formed between the current element and the position vector. This is theta, which is angle between the position vector and the current element. This is the P point at which I want the magnetic. So basically, four things occur. When we are studying about this, four things you should remember. This is just the basic diagram. Now you should know on what factors, on what things does this magnetic field depend on. So basically, four things. It is directly proportional to three things and inversely proportional to just a thing. Three things are what? Current element, and sign of the angle between the current element and position vector. So it is directly proportional to I, directly proportional to DL, directly proportional to sine theta. Now it is inversely proportional to R square. R square means the separation, this position vector which we have taken. So if I combine all of these, what should I get? dB is directly proportional to I dl sine theta divided by R square. We always put a constant here. So this is K I dl sine theta divided by R square, right? Now see, if this is the case, what is the constant here? Instead of K, we will write mu naught by 4 pi. This is the constant, okay? So I dl sine theta divided by R square. What exactly is this? I'll tell you. First, understand what is this mu naught symbol, permeability, which is mentioned. Permeability basically tells the dependency of the magnetic field on a medium. Suppose I have two magnets present and I'm taking them in air. So when I have the magnets present in air, they are getting a certain value of magnetic field. Now, when I have kept these two magnets in water, I'm getting a different value. When I'm putting these two from water to oil, I'm getting a different value. So how is the medium affecting our magnetic field? It is determined by this permeability. Okay? This is determined by the permeability of the medium. And for every medium, you have the value of permittivity and permeability. Permittivity will determine the effect of a field on electric field. Permeability will decide the effect of medium on magnetic field. That's just the difference. So mu naught is equal to 4 pi into 10 to the power minus 7. Well, that's what you have to remember. Now, if mu naught is equal to 4 pi into 10 to the power 7, this minus 7, this is the constant which we are using. So mu naught by 4 pi is what? It is equal to this, right? So it means this is the constant which you will be using. This is the constant term which you will be using. Now, any other medium which is there present. So what we do for other medium, we divide it by the permeability for air and we get a relative permeability. We get a relative permeability. So whenever we have a relative permeability, you just take the ratio. So R is the relative permeability. Like if you see, there are materials, ferromagnetic materials, iron, diamagnetic, all these we'll study in fifth chapter. So all these materials have different values of relative permeability, which you have to remember, but not in this chapter. So you can ignore the values right now. But this is just an example to show you how relative permeability varies. Fine. And this I'll tell you later. Till here only. Write down first. Okay, this part is also completed. Now see, I was telling you that if you have to write Biot-Savart's law in vector form, then how will you write it? So basically, if you have to write it in vector form, P is equal to mu naught by 4 pi I dl cross R by R cube we write. Why? See, dl cross R, this will give you dl sine theta R, and this R cube is there in the denominator. So 1 R will cancel this cube and we'll get our value back. Now, this you can write down. This is not very important. What is important is this. How to find out the direction. I'll tell you the formula for straight line and everything, but you should know what is the rule for calculation of the direction. Fine. So basically, we use our right hand. This is sufficient. There are two methods I'm going to tell you. Whichever method you prefer, you can use. You are free to use that. If you are uncomfortable with the first method, you're not getting your answers with the first method, you can always move to the switch to the second method. What is our first method? First method says that wherever the current is moving, we'll keep our hand in that direction. Suppose the current is moving upwards, so I'll keep my hand like this. Okay, suppose the current is moving upwards, so I'll keep my hand like this. Point A is here, right? Point A is like this. So I'll curl my fingers towards point A. Or what you can do, let me tell you the other method first. That is better. See, what you can do, I'll tell you this method first because this is a little confusing. This one which I was telling was easy so that you can do it later. See, if the current is moving up, like this is the current which is moving up, put your thumb in the direction of current. Alright, I've put my thumb in the direction of current. Then curl your finger towards the point and see which one here. If this is my hand, right? See, I have curled the finger. So fingers are pointing away from the screen, right? Outwards. Finger is pointing away from the screen, outwards like this. And what about B point? So look here. B point is here. If I curl my finger, so it is inwards. So at point A, look, thumb up because of current is up. A point, it is curled outwards. For out, we use this circle symbol. Okay, do not switch the hand, otherwise you'll get the exact opposite answer. Thumb pointing, see at P point where the fingers are going. Inwards, so across. Okay. Second one, which I was telling you, that I'll tell later. First, look like this. Current is going up, so my thumb is up. A point. Current is, my hands, fingers are coming out. It means it is outwards. Look at point B. Current. So I've kept my thumb. Current is here. I've curled. See the direction of the fingers at point B. So this is inwards. Look in the second figure. In the second figure, you can see that current is downwards, so thumb downwards. At point A, the fingers are going inside, so inwards. Look here, thumb down. At B point, the fingers are coming out, so this is outwards. Personally, I think this method is a little difficult to understand because where the finger is exactly getting curled is a little difficult to understand. But second method is always there. Second method is very simple. Second method basically says that, which I was telling, that keep your hand in the direction of current. Wherever is the point, curl your finger. Where is the thumb pointing? outwards, away from the screen, out to the page, out of the page, outwards. Direction of current is outwards. So here this is outwards. Look at B point. Current. If I keep my hand like this, B point is below. Can I curl my hand below like this? It's not possible. So I have to keep my hand like this, right? If I keep my hand like this, B point is downwards, thumb inwards. So this here, this is inwards. Look at the second figure. If I still keep my hand like this, point A is above. Can I curl it? I'll not be able to curl it. So what we have to do, if point A is here, if I put my hand like this, point A is above, I'll curl it. Thumb is going inwards. So this time this is inwards. Look at point B. Hand like this, point B down. Curl it. Thumb outwards. Is it clear, Sufyan, Taha, both of you? The direction is clear?
Yes.
Okay, see, one thing class, since we can use the cross product also, DL cross R. So just a small revision of cross product. In polar form, we write A cross B means AB sine theta. For Cartesian form, I cap, J cap, K cap, write three vectors I cap, J cap, K cap. If you move clockwise, use the positive sign. If you move anti-clockwise, use the negative sign. Two vectors getting multiplied, write down the third one which is left. So I cross J will give you K cap. J cap cross K cap will give you I cap. K cap cross I cap will give you J cap. Clockwise, all positive, I, J, J, K, K, I. Let's move opposite. I cross K, K cross J, J cross I. So negative. Same thing but negative. Write it till here, then we'll see one question. Yeah, from here you have to write, start writing. See class, when you put the formula here of Biot-Savart's law, this is mu naught by 4 pi mu naught by 4 pi. Current is 10 I dl. What is the dl? That is smaller length. It is 10 to the power minus 3 sine 90 degree and 4 pi r square. What is the separation? 10. So 10 square. This can be written as 10 to the power minus 7 into 10 to the power minus 3 by 10 to the power minus 1. This is equal to 10 to the power minus 11. Now see, if you put your right hand and curl the finger upwards, thumb is going inwards. So inwards is negative z axis. So minus k cap Tesla. This is how you have to write your answer. Write it.